Okay guys, chapter 9.5, the sine and cosine ratios. We're just going to start with our definitions and theorems. So starting out, our sine and cosine ratios. Again, this is your book's way of explaining it, but the easier way is just the sine of any angle is always going to be the ratio of the opposite side over the hypotenuse. The cosine of any angle is always going to be the ratio of the adjacent side over the hypotenuse. So how do we remember all three trigonometric ratios? We have this little acronym, SO, CA, TOA, and what this stands for is the sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. And I write that on any paper. I write it on notes, I write it on tests, just write it anywhere. It's kind of your little cheat sheet. Moving on, sine and cosine of complementary angles. So if we take a look at our first one here, and actually I'm going to back up just a step. Complementary, if you forgot, add to 90 degrees. So now, if I take a look at my first one down here, sine of A is equal to the cosine of 90 degrees minus A, which is actually equal to the cosine of B. That's a little confusing, so we have a little box down here, which is Y. So the first thing I'm going to do is I'm going to draw a picture. In our picture, we have a right triangle, 90 degrees. I'm going to label it. This is A, this is B, this is C. If you were in class this day, we talked about when you label an angle, you label it with a capital letter, versus if you label a side, you label it with a lowercase letter. So if I go up here to capital letter A, I go across the triangle. This is side, little a. Big angle B, go across the triangle. This is little side B. And big angle C, if I go across the triangle, this is little side C. Now I'm going to pick a reference angle. The reference angle I'm going to pick is angle A, and I'm going to label that theta. So just a couple things, because now we need to figure out what B is. So I'm going to pretend for a minute, and I'm going to ask the question, okay, well, if angle A is really 10 degrees, well then what would angle B have to be? And I'm hoping you're thinking 80. Okay, so we've got 90 degrees, 80 degrees, 10 degrees, add them all up, 180 degrees. Now I'm going to change it. So what if I made this like 20 degrees? Well, I'm hoping you're thinking, okay, this is now like 70 degrees, because once again, A and B have to add to 90 degrees. Let's try this one more time. What if I made angle A 30 degrees? Then angle B would have to be 60 degrees. Now, another way of recording this would be, okay, well, if angle A is 30 degrees, then angle B has to be 90 minus 30 degrees, which is 60 degrees. So now I'm going to back up and say, okay, well, if angle A is theta, another way to record that would be, okay, well, angle B has to be 90 minus theta, or whatever that is. So again, if I were to change this back to like 10 degrees, then wouldn't this one have to be like 80 degrees, or 90 minus 10 degrees? So for angle B, I'm going to put in 90 minus theta. Okay, now let's go look at this theorem. So I'm going to start with the sine of theta. Now the sine we just discussed is the opposite over the hypotenuse. So if I go back to theta, which is angle A, and I look to the opposite side, go across the triangle, that's going to be little a, over the hypotenuse, which is little c. The next thing I'm going to look at is I'm going to look at the cosine of 90 minus theta, which now takes me down here to letter B. So letter B, cosine is the adjacent over hypotenuse. So adjacent is going to be side A over the hypotenuse, which is side C. And then you're going to take a look at these two things, and And what do you notice? Okay, so they're the same thing. So sine of theta, cosine of 90 minus theta, same thing. Another way I can write cosine of 90 minus theta is the cosine of b. Another way I can write the sine of theta is the sine of a. And because they're the same thing, I can say that the sine of a is equal to the cosine of b. And that is where that theorem is coming from. Last theorem, angle of depression. An angle of depression is an angle formed between the horizontal looking down. Kind of the opposite of an angle of elevation. Remember, that one is the horizontal looking up. So this time, if we're looking down, I'm going to draw a picture. I'm going to have my little airplane up here. Okay, horizontal. Remember, another word for that is line of sight. So he's going to look straight out the window of the airplane, and then he's going to look down at something on the ground. So right here is going to be your angle of depression between the horizontal looking down. Now on this one, I'm going to put a knot. So if I have my airplane, there he is, and he looks down at the ground, and my airplane is this high in the air. This right here is not the angle of depression. Okay, keep in mind it has to be between the horizontal. There has to be a straight line coming right out of that airplane. So your angle of depression is the picture on the left. It is not the picture on the right. Just be aware of that and try not to make that mistake.